Hello, this is Ed Doherty, Suncoast Technical College, Precision Machining, and I'm going to talk about machining CO2 dragsters. We're looking at one right now. This came from Suncoast Polytech, and we already had machined this one on a Haas CNC machine. And this is in Mastercam 2018 right now, and these are all the operations over here. We have different operations we can use. We have 2D milling, 3D milling, multi-axis. We have a lot of different windows here, the home window. And these are for drawing, wireframe surfaces are solid or model prep. Drafting is for doing drafting. Mastercam is a CAD CAM system. It's probably not on the level of a Solidworks style drafting system, but it's okay. And a lot of times we have to do some more drawing when we're trying to machine something. Transforms for moving things around. Mastercam Art is an add-on, and this is a nice feature for doing artwork. Machine is what machine we're going to work on and use. View is just like it says, how we look at things, like wireframe, solid, translucent. I put that on. I got an inside view. I can move my views around here. I can move it with my right mouse button. There's some view buttons here, like isometric view. Toolpath is also what we were just showing a minute ago. I'm going to turn all these check boxes on are all different operations, and this is all the toolpath, but we're going to show you how to get there. So the first thing you want to do is you want to import your model, and I've actually pulled in a lot of different stuff here, and I actually in Mastercam I can put things on different levels or layers, and there's only three visible right now, and one was notes. So this is the green check mark means it's the active layer. I'm going to make this one the actives because I want to make that invisible. This is called a check plate. So actually we draw this in Mastercam. And the reason why we put that in there is we need to keep the front attached. And this is like a wall. So we're just building a wall so we don't want to machine past that. Oops, hitting the wrong button. Back to isometric. All right, so for now I'm just going to hide that. And the dragster body is showing right now. It's another set of check panels. So we had to make some bigger check panels because we could not machine as close as we wanted to. So we had to build a bigger wall, and we had to build a wall in the back because we do not want to machine behind here. I'm going to shut that off. And this is called a containment boundary. This wireframe box right here, I'm going to hit the top view. And I'm going to shut off the coordinate system with the F9 key right there. The containment boundary is used for roughing. It's not really in your tutorial, but we use it a lot in regular machining in order to remove material. It's a roughing boundary that we've set. So we can draw that in Mastercam. Axle points, we actually drew where the axles were going to be because we wanted to do them separately. Mastercam will attempt to machine anything it sees when they're talking about a solid body. All right, so I'm going to shut all those off, and we just have the body of the car. I'm going to go back to isometric view. I'm going to hit the right button, hit fit, puts it in the middle. And I like using the unzoom key just to unzoom a little bit, even though I can zoom with the middle wheel button. All right, let's go step by step here. Now I'm going to shut all these groups off with this one. Let's see. Yep. Now they're unchecked. These are like little folders, and I can compress the folders. Okay. So there are 11 operations here. This one's called a manual entry. This is actually for notes that I'm putting into my code. This is something I do uniquely. This little red arrow, it means that's an insert area. So if I wanted to insert there, I can move this up or down. If I wanted to add an operation. And I'll put this on the bottom. Okay. So I'm going to turn this one on, surface high-speed roughing, which was not really part of the normal tutorial that you would do. The parameters are, let me drag them over here. It's roughing, so it says area roughing, model geometry, so it's picking, I actually picked the model. You can see it says green right here. Notice it's green. And avoidance would be actually those, I have to shut this window off. Would have been the, not that one, but these big ones here. Okay. Back to toolpath, so parameters, and back to here. So avoidance is these red areas, and machining of the other entities. Okay. Toolpath control, it's asking me, do I want to stay containment boundary, which is the thing I drew, and what's inside or outside. Which tool am I going to use? So I was using a 9.52 millimeter ball end mill to do the roughing, and I had to set RPMs and feed rate here. Cut parameters, so there's a lot of little steps here, kind of motion, linking with something called linking parameters. We're running in metric mode right now, so the clearance plane means how far does the tool go up to clear boundaries. All right, so I made all those selections and ended up with this tool path right in here, right inside there. That's also cutting the bottom. Now we look at this, the blue lines are where the tool would go, and the yellow lines are what we call rapid movement. So rapid, and the other ones are controlled at a certain feed rate. So the yellow would be as fast as the machine can move, not meant to cut anything, and the blues are for what we call machining. So right now I have it on side view. So if I want to change my planes, I have actually drew different planes here. And we're on a 0 plane, we're calling it 180. So we want the STC bottom view. So now this is now our new top view called bottom, if you can make sense out of that. All right, so now we're looking at it from this point of view. We're going to go back to toolpath here. So then we added this one in here, which was this toolpath. You notice it jumped up and over, so it knew not to go through here. We told it we wanted to go up and over, and it actually was spiraling in there and staying within inside that boundary. Okay. Then we added some side cutting. So this came from, let's see, this point of view right here. So that means I had to change my planes. My planes were, I believe, A0. Yes, we go. And isometric. I like using the isometric, and I'm going to do fit to unzoom it. And notice it avoided machining because I set this as my boundary. So it didn't violate this area. So we still stayed attached. And all the extra wood was removed. We didn't need to remove anything from the bottom. We had some removal to do there. So this is what we call roughing. So this other side is pretty much a mirror image of that side. We can only get so far down here. We can't go underneath the car. We have to rotate the car to the 180 plane. So this is the view from this angle. So this would be working on that side. All right, so I'm going to pick it up where you would usually be in your tutorial, which would be on the finishing. All right, we have an ability to change tools with an automatic tool changes, so we wanted to utilize those functions. Now, right now, this is the, sorry, no, we're still in OptiRough, sorry. I'm going to go to the finishing toolpath. And That is the inside. If you can see the inside, it's very, very fine increments there. We call this step over, actually. Step over, so it's going up and down, inside and out. So if we get a visual, we can get a quick verification here. Notice the tool. And we can turn all these on and off with these buttons. Come on back, there we go. I'll turn that back on. There we go. Move this out of the way. Then I hit this play button. There we go. Now you can see the tool moving it down. So that's why you see the blue lines here now. So we can see the motion of what's going to happen. And because we're in transparent view, we can see it staying right inside the solid model boundaries. And we picked this area. We told it not to violate this outer ring, because if not, it would try to machine anything it could. So we said, nope, we just want to stay right inside here. Okay. Go on to the next one. Turn that one on. And now we have finishing toolpath over here also. And the same thing. Turn on the tool. There it is. And the same motion. We can speed this up. Right. But we're just trying to get an idea of, is it cutting correctly? Okay, I'm going to unzoom this. Hit the fit button. And now we're going to work on the sides. I'm going to flip the planes around. I'll go back to the 180 view and do isometric. We're going to go to this one here. Turn that toolpath on. Oh, right side. Nope, we're on the wrong side. Okay. Let's flip it around. Let's see. Plane A0 this way. Okay. All right, this is our point of view now. So we machine the wheel wells, and this is finishing cuts here. We're going about a little bit beyond the halfway point. And we've got our little walls here so we don't violate the front or the back. That's our work holding positions. Okay, so we can run a quick simulation on that also. Turn on toolpath. Little box that says backplot. This is our tool again. I'm going to put an isometric view, a little better orientation. Hit the play button, and same thing again. It's doing very fine cuts. We call this the spacing in here. We call this the step over. So if you want finer increments, you'd have a smaller step over in order to get it really, really smooth. But it also takes time. So we're trying to balance quality and time. All right, so now we're going to do the bottom side, which as you can see is a duplicate of the top or the side view. We'll change planes. We're going to use this. Sorry, we want the 180 view. Isometric. And we'll hit the play button again. Okay. Oh, sorry, that's a full simulation. Well, we might as well just watch that. Full simulation, you can put solid material in the air, and I actually prefer to have an exact replica of the wood, because if I'm doing the roughing, we would want good representation of what's going to happen. So right now, that is the cut on this side. So we can actually see the cuts. We can see it, the little dimples where the axle holes will be. Of course, we're just showing that one operation. All right, let's actually turn all the finishing operations on, which would be here. I'm going to hit the control button here, 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 and here. Okay. Turn them all on. They're all on now. And we're going to go to full simulation. And I'm going to turn off operation change and let it go from beginning to end. I also had it change colors on each operation so I could tell which one was doing what. So notice one does halfway and the other, but they blend together. All the blends look good. The thing looks perfect. Let me turn this around again and unzoom it. So over here it says total time 16 minutes and 3 seconds. So we can know how long all this will take. And so we wanted a finer increment. We could go in here to like surface high speed parameters. And these are the different types of paths right now. We're using raster right now, finishing. These are the selections of the green is the entity, they call it. Tool path control. Let's see, cut parameters right here. Here it is step over. So it's doing 0.5 millimeter step over. So that would be the spacing here. So we can shrink that up. We're doing a zigzag pattern, or we could do a one-way. One-way would take more time, so zigzag is quicker. Transitions. This is orientation of how far up and down it goes. This one we have to add in. It detects the high and low limits. So there's a lot of what planes we're trying to identify. So we'll take you step by step to do that, but right now we have a finished product here, and we want to create code for the machine. You hit the G1 button, or from here, you X out of that. Right here under machine, the big G1 is generate post. Post processing is the creating the G code for the machine. I'll hit that. It says I'm going to write a file. I'm going to put an NC extension on that, which is what we want to run in our machine. It says not all our operations are posted because we're just actually doing finishing only operations. And I'm going to answer the question, post all no. And we're going to write a program. We have a similar program name, but we're going to overwrite that one. You want to be good at your file management because you want to make sure you're using the correct program. All right, so this is our program, and we would save this on a USB and run that. So from this point, I could do a save as and put it in a USB and bring it to my machine, load it in and run. Okay, thank you very much. We'll bring you up to speed about how to get to all these toolpaths. Thanks.